Hi friends, today we are learning the torque acting on a current carrying loop. Okay, so we have a north pole and south pole, and in between them we placed a loop, a current carrying conductor we placed. Okay, then this current carrying conductor will experience a torque. So we are going to derive the equation to find that torque. Okay, so this is that current carrying loop. I am drawing it along. So we are passing current to it. So here we have north and south poles. So in between north and south pole, we know that there will be definitely magnetic field lines, is it? So just look here. Here I am naming this loop as A, B, C, D. Just look at this BC. This is the field line, magnetic field line, and this is BC. So BC and this magnetic field line both acts in same direction. Both are parallel. So the angle between them is what? The angle between them is 0. Then look at this portion AD. Okay. Here in the case of BC as well as this AD portion, this field lines are parallel or anti-parallel to magnetic field lines between north and south pole. So this field line is parallel to magnetic field line is parallel to BC as well as AD. So the angle between them is 0. So we know that the equation to find the magnetic force is I into L cross B. Okay, here this is the length BC, the length BC, let it be A. And this length of AB, that is B. Okay, so this A and as well as the field line B, they are in same direction as they are parallel. So the angle between them is 0. So IL cross B, it becomes ILB sine 0, that is equal to 0. So the magnetic force acting on BC as well as AD of this current carrying loop is 0. Now we have to consider only this AB as well as CD. Okay, we are considering AB as well as CD. So, first of all, this AB that is equal to B and this BC, the length that is equal to A. So, here also it is B. Now, we are going to find the current flowing through this AB as well as current flowing through this CB. We have to find it. Okay, so F that is equal to IL cross B. Here F equal to I B B. In which section? In this section AB. Here the current is IBB. Magnetic force is current is I and the magnetic force is IBB. Here actually it is IB cross B. I small b cross B. Look here. Here the magnetic field lines as well as this length that is perpendicular to each other. So sine 90, IBB sine 90, that is equal to IBB. Then look at this section, that is CB, CD. So here also F equal to field line, it is perpendicular to B. So it is sine 90. So IBB. Here also it is IBB. Okay. We have to find what? We have to find the torque. Okay, torque acting on it we have to find. So torque basically that is equal to R cross F. Okay, and here in the case of this loop, what is R that we have to find? This is B and this is A. Current is passing. Then this is A, B, C, D. The contribution of BC as well as AD, we can neglect it. Okay. Then the contribution of AB, the portion AB is IB and the field line B. Then the contribution of the portion CD, that is also I, what it is, IBB. Okay. Then what is R here that we have to find? Okay. So a force is acting. This force, it is acting in which way? Yes, one force is acting in this direction and other force is acting in the opposite direction. That is, for this loop ABCD, A, B, C, D, one force is acting in this direction, another force is acting in this direction. Okay, so this is B and this is A. Okay, so here we have a force that is due to FAB, the portion AB, that is FAB, and here we have a force that is FCD, and in between them the distance is A, and the center of that force, that is A, that is we can take it as O. So this will be A by 2 and this distance will be A by 2. Okay, so here the R in both cases it is A by 2 and A by 2. Okay, so the torque that is equal to R cross F, here it is A by 2 into IBB plus then the force due to the second portion, that is A by 2 into IBB again. Okay, so the total torque that we have to find, that is equal to IABB. So AB, what is AB? Let's recollect it. This is the loop and this is A and this is B. So AB means the area of that rectangular loop. So it is equal to IAB. Is it? IAB. So what is IA? IA, it is magnetic moment. So torque equal to MB. In this case, sine, actually we have sine of angle, but here we have sine 90. Okay, that's why we don't write it, but in actual case we have M into B into sine theta. So MP sine theta, it means M cross B. Okay, so the torque acting on a current carrying conductor in a magnetic field is M cross B. So just recollect the case of electrostatic field. There the torque is P cross E. Okay, here it is M cross B. Okay, so that's all. So what we had discussed here, we have a current carrying loop. Okay, so we are providing current, so it carries current, and that loop is A, B, C, D, and it is placed in between north and south pole. And when we are passing current through it, what happens? It will experience a torque and it will rotate, and that is what, that is actually it is the Moto principle. So what's the equation to find that torque that we had derived? Tau equal to M cross B, where M is the magnetic moment, M equal to I into A, where A is the area of the loop, I is the current. Okay, thank you. If you like the class, please subscribe the channel and mark your attendance by marking the like button. Thank you.